Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, we are going to learn a very important concept, that is crystal field splitting theory. In crystal field splitting theory, we are going to learn how to write the electronic configuration, to calculate the magnetic moment, to calculate crystal field splitting energy value. So these are the important concepts we are going to cover in this video, children. Then come on, let us start with the first concept, that is how to write the electronic configuration, that is for crystal field splitting theory. Here it is. To write the electronic configuration for CFT, you should know the basic information is that whenever there is a strong field ligand, remember children, whenever there is a strong field ligand, then there is a pairing of electron takes place. Whenever there is a weak field ligands, then there is no pairing of electron takes place. You can see here the distance between the two sets of d orbitals. It is they are far away from each other. That is why that pairing is taking place. You can observe in this side, when the weak field ligand is there, the two d orbitals, that is two sets of them, are very close to each other. That is why there is no pairing takes place. Very important, children. Strong field ligand is equal to pairing. Weak field ligand is equal to no pairing. Now let us start with the first D1 configuration. If I take D1 configuration, here 1 is nothing but 1 electron. So first I will fill in 1 electron here. Sir, I have filled 1 electron and it is entering what? T2G. So I will write the electronic configuration as T2G1. And how many electrons are there in Eg? There is no electron. Therefore, I will write Eg0. The number of unpaired electrons right now is 1. Therefore, N is equal to 1. I'll go for the next one. You can observe here, whenever a weak field ligand is there, I'll take the next one. That is same configuration of D1. The first electron will enter to the Eg set, T2G set, sorry. Therefore, that is T2G1. Eg is 0, Eg0. The number of unpaired electrons is how much? The number of unpaired electron is 1. Let me go for next configuration. That is D2 is equal to 1 more electrons enter to the T2G set. Therefore, I'll write T2G2. And here Eg there is nothing. Therefore, I'll write 0. The number of unpaired electrons 1 and 2. Therefore, N is equal to 2. When I take again D2 is equal to 1 electron here. Therefore, T2G2. In T2G2, how many electrons? 1, 2. Therefore, T2G2. Therefore, number of electrons in Eg, it is 0. Therefore, number of unpaired electrons 2. Therefore, N is equal to 2. I'll go for the next one. D3. If it is D3, then I am going to fill 1, 2, 3. Therefore, T2G3 electrons. In Eg, there is no electron. Therefore, how many unpaired electrons? 1, 2, 3. Therefore, unpaired electrons 3. N is equal to 3. And the same, D3, that is 1, 2, 3. Therefore, T2G3. And here it is Eg0. How many unpaired electrons? 1, 2, 3. N is equal to 3. If you observe here, children, from D1, D2, D3, from D1 to D3, the number of unpaired electrons are same in both the cases. It is same. The electronic configuration for both of them, weak, strong field as well as weak field, it is same. Now we'll go for next one. D4. How many electrons? 4 electrons. 1, 2, 3. Because it is a strong field ligand, the electron will get paired up here. Pairing is taking place. Therefore, in T2G, how many electrons? 1, 2, 3, 4 electrons. So I'll write here T2G4. In Eg there is no electron. I'll write Eg is equal to 0. How many unpaired electrons here? 1, 2. Therefore N is equal to 2. Because it is a weak field ligand, if I take D4, 1, 2, 3, the fourth one will move here. Because it is a weak field ligand, there is no pairing takes place. Now what happens? T2G, 1, 2, 3. Eg is how much? Eg is 1. Eg is 1. I'll write Eg1. So how many unpaired electrons? 1, 2, 3, 4. Therefore N is equal to 4. I'll go for D5. T2G, 5. 1, 2, 3, 4, 5. T2G5. In Eg there is no electron. Therefore how many unpaired electrons? 1 unpaired electron. Therefore N is equal to 1. I'll go for D5 for a weak field ligand. Therefore 1, 2, 3, 4, 5. So how many electrons are there now? Yes, now there are in T2, G3 and here it is Eg2. Therefore how many unpaired electrons? 1, 2, 3, 4, 5. Therefore N is equal to 5. I'll go for the next one, that is D6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'll write T2G6. In Eg there is no electron. I'll write 0. How many unpaired electrons are here? There is no unpaired electron. Therefore I'll write N is equal to 0. Next I'll just go for the next one, that is D6. So now you should observe here, where do the electrons will enter when it is D6? 1, 2, 3, 4, 5. Now the next electron will come here, pairing up here. Therefore 1, 2, 3, 4. Therefore T2G4 and Eg is 2 electrons. How many unpaired electrons? 1, 2, 3, 4. Therefore 4 unpaired electrons. I'll go for D7. D7. 1, 2, 3, 4, 5, 6, 7. The seventh one will move up. So I'll write here T2G6 and Eg is how many electrons? 1. N is equal to how much? How many unpaired electrons can you see here? It is 1. 1 unpaired electron. I'll write N is equal to 1. I'll try for D5 now. D7, sorry. D7. 1, 2, 3, 4, 5, 6, 7. D7. T2G 1, 2, 3, 4, 5. T2G5. Eg is 2. How many unpaired electrons? 1, 2, 3 unpaired electrons. Therefore N is equal to 3. I'll go for D8. 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 1, 2, 3, 4, 5, 6. 7, 8. 7, 8. So how many electrons are here? T2G6 and here Eg2. And how many unpaired electrons? Here it is. How many unpaired electrons? 2 unpaired electrons. So I'll write N is equal to 2. Then again I'll go for the next one. That is D8. 1, 2, 3, 4, 5, 6, 7, 8. Therefore T2G6, Eg2. How many unpaired electrons? N is equal to 2. Then I'll go for D9. T2G 1, 2, 3, 4, 5, 6, 7, 8, 9. T2G6. Eg is 3. Eg 1, 2, 3. How many unpaired electrons? 1 unpaired electron. N is equal to 1. I am sure even in case of weak field ligand, it will be the same. I'll just write it down. D9 is equal to T2G6, Eg3, N is equal to 1. In the same way, D10, T2G6, Eg4, N is equal to how many unpaired electrons now? There is no unpaired electron, therefore N is equal to 0. The same thing, D10, T2G6, Eg4. Eg is 4, 1, 2, 3, 4. Therefore N is equal to 0. Hope you have understood how to write the electronic configuration now. Let me use this electronic configuration to calculate the magnetic moment, to calculate crystal field splitting here, crystal field splitting energy, children. Sorry. Let us do that now. Here is the formula, children, to calculate the magnetic moment. That is, magnetic moment is equal to square root of n into n plus 2 Bohr magneton. Here n is the number of unpaired electrons. For example, if they have given a D5 configuration and that is for a strong field ligand. For a strong field ligand, you can observe here for D5 it is going to be number of unpaired electron is 1. Therefore, I will just take it as for D5 1 into 1 plus 2, that is going to be how much? That is going to be square root of 1 into 3, or that is equal to square root of 3. What is the value of square root of 3? You can easily calculate. That is going to be it is going to be how much? It is going to be 3.87. In the same way, if they ask you to calculate the D4 configuration for a weak field ligand, how do you do it? So for a weak field ligand, here this side for D4, for a weak field ligand, you can observe the n value is 4, the number of unpaired electron is 4, therefore n is equal to 4. Here it was n is equal to 1. For D4 weak field ligand, n value you can observe here it is 4. Therefore I will write 4 plus 2, that is equal to square root of 6 4s are 24. Then what is the value of square root of 24? It is going to be 4.89 Bohr magneton. Here also this is Bohr magneton. Hope children you have understood how to calculate the magnetic moment by using the electronic configuration of CFT. Now let us go for the next one. Now the concept number 3 is to calculate Cfse, crystal field splitting energy. The formula to calculate crystal field splitting energy, you can observe here, Cfse is equal to T2g into minus 0.4 plus Eg. This is the formula to calculate the Cfse, crystal field splitting energy. I hope now you know the formula. Let me try for a strong field ligand with the configuration of D6. So where is D6? Here is D6. For a strong, I have written this side strong field ligand, this side weak field ligand. The strong field D6 is here. You can observe here T2G6. 6 electrons are there for T2G. So I will write here in the formula, that is Cfse is equal to T2G6 into the formula minus 0.4 plus for D6 for a strong field ligand. What is Eg? Eg is 0. Therefore I will take 0. If I take a 0, what happens now? It is going to be 6 into minus 0.4 plus 0. When we simplify this, we will get a value of minus 2.4. This is the value of strong field ligand D6. If I try, you can try for a D5, which is a weak field ligand. It is very simple. You can easily do it. You have the formula here. You can see for a weak field ligand D5, T2G is the T2G3 and Eg2. So according to the formula, first I will take here, that is T2G is how much? 3 for D5. So I will take here 3 into minus 0.4, that's there in the formula, plus What is Eg for D5? Eg for D5 is 2. I'll take 2. So when you simplify this, you will get the answer. So try for some more of the configuration, children, and calculate Cfse value, crystal field splitting energy value. I hope you have understood all the 3 concepts which we have discussed in this video, that is how to write the electronic configuration of CFT, calculate the magnetic moment of CFT, and calculate Cfse value. Yes children, for more videos, subscribe to my channel. If you have any doubts, you can please comment me, and I will be coming with the new chapter in my next video. That's it for today. Thank you. See you again.